Now, the next standard limit I'm going to talk about, which is the seventh one, is a limit involving infinity. So in mathematics, infinity is represented by this symbol. Now, the limit of a function f of x as x approaches infinity, or what we mean, it becomes very large, is denoted as limit of f of x as x approaches infinity. So now let's look at some instances of limits involving infinity. So the first instance, if you have limit of 1 over x to the power n as x approaches infinity, this equals 0 if n is a positive index. For instance, we have something like 1 over x to the power 5, 1 over x to the power 6. If the index is positive and the limit is approaching infinity, then the limit is equal to 0. Let's look at something. Remember, if we have 1 to the power x to the power 5 and we have the limit of this function as x approaches infinity, then this is going to be equal to 1 over infinity to the power 5. Now let's look at something. If you have 1 over 1000 to the power 5, infinity means a number that is getting larger. It does not have a specific value. And so if you have this value to the power 5 and it's being divided by 1, you realize that it is approaching 0. Let's pick our calculator and then let's divide 1 by an infinite value. So for instance, 1000 to the power 5. That is 1 times 10 to the power negative 15, which is a value that is absolutely 0. So now we've learned that if you divide a number by a larger value, then it becomes 0. So 1 divided by infinity equals 0. Likewise, 1 divided by infinity to the power n is also equals 0. Now the second instance is that limit as x approaches infinity of the function x to the power n does not exist if the index n is positive. The third instance we are going to talk about, if f of x is a rational function, that is g of x over h of x, then the limit of f of x can first be found by dividing the numerator and the denominator by the variable with the highest index or power of x. Let's look at an illustrative example on that. Now let's try to find the limit as x approaches infinity of the function 5x squared minus 1 all over 2x squared plus 1. Remember, we've already looked at rational functions when x is approaching a. A is a specific value, but in this instance, which is a limit involving infinity, we are talking about x approaching a non-specific value, which is infinity. And so, if you are to calculate for the limit of rational functions as it tends to approach infinity, then we are saying that we can only find the limit by first dividing the numerator and the denominator by the variable with the highest index or the power of x. And so taking this example, this is a rational function and it is approaching infinity. If you want to find the limit of this function, the first thing we are to do is to find the term with the highest degree. So now, if you look at the variable x, it's having the highest degree of what? 2. So 2 is here now, also 2 is here. So with this example, x squared is what we are going to be using to divide both the numerator and the denominator. So we are going to have limit as x approaches infinity of 5x squared over x squared minus 1 over x squared all over 2x squared over x squared plus 1 over x squared, right? Now we have limit as x approaches infinity of the function. Now x squared can cancel x squared out. So we have 5 minus 1 over x squared all over 2x squared over x squared. X squared can cancel these and it is left with 2 plus 1 over x squared. Now if you want to plug in infinity, then we are going to have 5 minus 1 over infinity squared all over 2 plus 1 over infinity squared. Now we know 1 over infinity or infinity squared is 0. So we are going to have 5 minus 0 over 2 plus 0. And that is going to give us 5 on 2, which equals 2.5. Of course, you can use the calculator to compute this. So let's pick our calculator. So this is our calculator. Now, we want a larger value. So I'm going to pick 100,000 and then store it as x. And I'll come back and then compute it using the calculator. So we have 5 alpha x squared minus 1 all over 2 alpha x squared plus 1. We hit the equal to button and we're having 2.5. So let's pick another example. Let's have limit of 7x over x minus 4 as x approaches infinity. Now, The highest degree is 1 in this case. And so we are going to pick x to the power what? 1. So we are going to divide the numerator by x, the denominator by x. So we are going to have lim as x approaches infinity, 7x over what? X all over x minus 4. Then we divide x by x. Then we divide 4 by x. Now these cancel these, so we are going to have limit as x approaches infinity of 7 over, this becomes 1 minus 4 on x. Now if you are to plug in infinity into the function, we already know that the limit of a constant is always the constant. So the numerator is going to be what? Still what? 7. Then this becomes 1. Limit of a constant is also a constant. Then minus, now if you plug infinity here, 4 divided by infinity equals 0. And so if you keep on dividing 4 by a larger value, you realize that it is approaching 0. So 4 divided by infinity is 0, just like 1 divided by infinity is 0. So you're having 0, which equals 7 over 1, and that equals 7. So limit as x approach infinity of the function 7x over x minus 4 is equal to 7. Alright, so just to remind you, if you have f of x equals x squared plus 3 all over x, and you are to find the limit of this function f of x as x approaches infinity, then what you are going to do is that this time around the highest degree becomes what? X squared. And so you are going to divide the numerator and the denominator by x squared.